For the UPSC Civil Services Examination, IAS Mains, Chemistry Optional Paper 2 requires deep conceptual clarity, application of theoretical rules, and clean orbital diagrams. Pericyclic reactions is a high-scoring, high-weighted chapter that typically appears in both compulsory and optional sub-questions. Here is a curated set of selected high-yield questions with model answers, structured exactly as required for the exam. Question 1, 10 marks, using frontier molecular orbital, FMO, theory, show that the thermal electrocyclic ring opening of trans 3,4-dimethylcyclobutene is conrotatory. Model answer. 1. System analysis. Cyclobutene ring opening is a 4-pi electron system, 2 pi bonds involved, 1 pi bond and 1 sigma bond undergoing cleavage. Under thermal, delta, conditions, the ground state electronic configuration determines the outcome. 2. Identifying the reference FMO. For a 4-pi electron system in thermal conditions, we look at the highest occupied molecular orbital, HOMO, of the corresponding open chain conjugated system, 1,3-butadiene, to determine the pathway. The pi molecular orbitals of a 4-pi system are psi_1, psi_2, psi_3, psi_4. The thermal ground state HOMO is psi_2. Symmetry of psi_2. It has a C_2 axis of symmetry, antisymmetric with respect to the mirror plane, M. 3. Orbital rotation mechanism. To form the new pi bonds or open the ring predictively, the overlapping lobes of the breaking sigma bond must rotate such that the emerging pi orbitals match the symmetry of psi_2. Since psi_2 has C_2 symmetry, the signs of the terminal lobes are opposite on the same face, e.g., top left is positive, top right is negative. To maintain constructive overlap, both methyl groups must rotate in the same direction, either both clockwise or both counterclockwise. This movement is conrotatory. 4. Stereochemical outcome for the trans isomer. When trans 3,4-dimethylcyclobutene undergoes conrotatory rotation under thermal conditions, one methyl group rotates inward and the other rotates outward. This specific rotation yields the 1E3Z-1 4-dimethylbutadiene isomer cleanly. Question 2, 15 marks. A. State the Woodward-Hoffmann rules for 2+2 and 4+2 cycloaddition reactions under thermal and photochemical conditions. B. Explain why the 2+2 cycloaddition of ethylene does not take place thermally but proceeds smoothly under photochemical conditions. Model answer. A. Woodward-Hoffmann rules for cycloaddition. The selection rules depend on the total number of pi electrons, 4n vs 4n plus 2, taking part in the concerted mechanism, system. Number of pi electrons. Thermal, delta, allowed. Photochemical, H, nu, allowed, 2+2, 4n, n equals 1, antirafacial, _s, pi plus _ pi, superfacial, _s, pi plus _s, pi, 4+2, 4n plus 2, n equals 1, superfacial, _s, pi plus _ pi, antirafacial, _s, pi plus _ pi. Note, geometrically, an antirafacial approach in small chains like ethylene is highly strained and practically impossible, making thermally allowed 2+2 non-feasible. B. FMO analysis of 2+2 cycloaddition of ethylene. Let us analyze the interaction between two interacting ethylene molecules, component A and component B. For a reaction to happen, the HOMO of one component must interact constructively with the LUMO of the other. 5. Under thermal conditions, delta, component A, HOMO, for ground state ethylene, pi squared, the HOMO is psi_1, symmetric, both lobes on the same side have the same sign. Component B, LUMO, the LUMO is psi_2 **, antisymmetric, lobes on the same side have opposite signs. Interaction evaluation. When they approach in a parallel, superficial manner, one side shows bonding overlap, plus with plus, while the other side shows anti-bonding overlap, plus with. Because the net overlap cancels out to 0, the thermal superficial 2+2 process is symmetry forbidden. 6. Under photochemical conditions, H, nu, a radiation excites an electron from psi_1 to psi_2 * in one of the ethylene molecules. Component A, excited state HOMO, OMO, becomes psi_2 * antisymmetric. Component B, ground state LUMO, remains psi_2 * antisymmetric. Interaction evaluation. Now, both interacting frontier orbitals have identical C_2 symmetry, psi_2 interacting with psi_2. When approaching face to face, superficially, positive lobes match with positive lobes, and negative lobes match with negative lobes at both ends. This results in a constructive bonding overlap. Therefore, the photochemical 2+2 cycloaddition is symmetry allowed. Question 3, 15 marks. Predict the products with appropriate stereochemistry and mention the name, type of Perry-Clark reaction involved in the following transformations. Heating of 2E, 4Z, 6E, text, octatriene. Reaction of 1,3-butadiene with maleic anhydride. Heating of allyl vinyl ether. Model answer. 7. Heating of 2E, 4Z, 6E, text, octatriene. Type of reaction, thermal 6-pi electrocyclization. Analysis. A 6-pi electron system falls under the 4n+2 category. According to Woodward-Hoffmann rules, thermal electrocyclization of a 4n+2 system proceeds via a disrotatory pathway. Stereochemistry. In 2E, 4Z, 6E, text, octatriene, the terminal methyl groups point towards each other. CIS-like placement structurally within the polyene orientation. A disrotatory movement, one clockwise, one counterclockwise, brings the methyl groups to the same side of the newly formed ring plane. Product, CIS 5,6-dimethyl-1,3-cyclohexadiene. 8. Reaction of 1,3-butadiene with maleic anhydride. Type of reaction, 4+2, cycloaddition, Diels-Alder reaction. Analysis. 1,3-butadiene acts as the 4-pi component, diene, and maleic anhydride acts as the electron-deficient 2-pi component, dinephile. The reaction is thermally driven. Stereochemistry. Diels-Alder reactions are strictly stereospecific and proceed via superfacial assimilation. The CIS geometry of the carbonyl groups in maleic anhydride is preserved perfectly in the product. Product, CIS 1,2,3, 6-tetrahydrophthalic anhydride, endoproduct forms preferentially due to secondary orbital interactions. 9. Heating of allyl vinyl ether. Type of reaction, 3,3, sigmatropic rearrangement, Claisen rearrangement. Analysis. It is a concerted, unimolecular isomerization involving 6-pi electrons in a cyclic transition state. Numbering begins from the atoms forming the breaking sigma bond. Oxygen is position 1, carbons track outward. The old sigma bond between position 1 and 1 foot cleaves, while a new sigma bond forms between position 3 and 3. Product, pent-4-anal, and gamma, delta unsaturated carbonyl compound. Tips for writing pericyclic answers in IAS mains. Always draw clear phase shaded orbitals, use shaded circles for positive, plus, phases and unshaded circles for negative, phases to make orbital overlaps instantly clear to the evaluator. Explicitly mention the parameters. Always specify the type of system, 4n or 4n+2, mode of activation, delta or H, nu, and the mode of rotation, approach, con, dis or supra, antara.